All right, hi everybody. Really excited to bring this webinar to you today. We're going to go ahead and get started because we got a lot of material to cover. But again, very thankful to Esri to be partnering with us on this. This is the first webinar in a four-part series that we're going to be doing this year. And this one's entitled What's Ahead for Imagery and 3D Data and Utilities. So I'm going to be turning it over to the Esri team here very soon. But quickly, I know a lot of people are not familiar with UIGA. So quickly, I wanted to go through and just kind of talk a little bit about who we are and what we do. My name is Ken Manis. I'm one of the co-founders of UIGA. I've been with the company since its inception in 2021. I am mainly responsible for working with utilities. My partner, Todd Hagan, who is also on the call, is responsible for working with the solution providers out there. So really, we are a community that is all about imagery, the vast amounts of data that are coming into utilities right now through all sorts of capture mechanisms. And we're trying to get utilities connected in these following areas: asset inspection, veg management, storm response, and wildfire mitigation, really to learn about best practices, share challenges that they're going through, and just really build a community. We're also there to vet different solution providers and make sure that the utilities are aware of everybody in the space. And what we do is we have a couple of in-person events each year, and we have an online community that you can be a part of, as well as about 8 to 10 virtual calls each year that utilities are invited to. So we can definitely share some more information and let everyone know a little bit more about who we are, and we'll send some QR codes to you as well. But we couldn't do this without our partners. So as you'll see in the top of this slide, AEIC, the Association of Edison Illuminating Companies, has been with us from the start. Distributech, now DTech, we have been working with them for 3 years, going on 4 years next year. We have our own standalone event at Distributech that takes place on the front end of the event. And we also are on the board of their regional events. So we're very thankful for that partnership. Epri has been working with us for the last couple of years. We're going to be having them speak to our audience next month. And of course, Esri has been with us from day one. So they've been a great partner, and they are actually our exclusive geospatial partner. So thanks to Esri for helping us with this. This is just a quick slide. This is by no means all the utilities that we're working with, but this is the utilities that have been kind of engaged with us over the years, have joined our calls, been to our events, or been kind of members on the online community. You'll see that we have mostly a North American audience, but we do have a pretty big contingent out in Australia, which is pretty cool. And they have been with us since day one. So we're really excited to keep this list growing. These slides will be available, so I'll be happy to share with the people that are on this call. But again, just wanted to kind of show you who we're working with in the industry. Again, my name is Ken Manis. Todd Hagan is my business partner. There's a QR code for you to check out our online community and get involved in that. And then also there's a QR code to get involved in our page on LinkedIn. So that's all that I have for now. I'm going to go ahead and turn it over to the Esri team. We're super excited to have Tom Linzen and Cody Welch talk with us today. They have talked to this group before, our UIGA group. They're fantastic presenters. We went through the presentation yesterday, and there's a wealth of knowledge that's going to be shared today that I think is going to be great for everybody on this call. We're super excited for it. So with that, I'm going to turn it over to Tom, and we'll get going.
Thanks, Ken. Thanks to Ken and Todd for all the hard work you guys do with UIGA to bring this together. So again, Tom Linzen with Esri. Cody and I are going to present a few things today. So one of the things that we talked about at Distributech is in the last session was to help bring the geospatial context of UIGA to the forefront and help our members of UIGA really understand some of the capabilities and talk about user experiences and those kinds of things. So we're real excited to get this thing started. It'll be a 4-part series. I think, as Ken mentioned. So today is more about helping you understand what you have. So um, go ahead, next slide, Cody. We know that in the electric industry especially, but across, if you think about munis and rural electrics and investor-owned utilities, there's a lot of challenges facing organizations today. Aging infrastructure and improving resiliency. And there's just a boatload of data coming at you. So our goal is, and as Esri, is to constantly improve our technology to support those challenges that you have and to provide the right foundation so that you can move forward in the goal of being more proactive and breaking down silos to do more effective and collaborative work across the organization. Imagery and remote sensing, point clouds, 3D, those are all part of it. If you think about GIS, first of all, I want to say thank you to most of the folks that are on the call for being Esri customers in some way, shape, or form. But as many of you as users know, GIS isn't just a map. It's brings so many different aspects together to really solve those challenges that we talked about earlier. And imagery and data collected in the field, Lidar data, point cloud data, inspection images, image surface models, terrain models, those are all a big part of what you leverage when you're using our technology to solve those problems. Next slide, please. We bring this effort to organizations across the globe. One of the things that I think helps Esri as we provide geospatial solutions and GIS capabilities to our customers is the fact that we work with hundreds of thousands of organizations that have lots of different challenges. This benefits everybody in every one of the industry niches. And if you see on here, 15,000 plus of those are utility companies. So we're in the trenches with you guys, helping provide a framework that you can leverage to support those challenges. Next slide, please. The way we're looking at and have addressed imagery and 3D point cloud data as it starts to become more the norm in everyday work is to look at it from a total workflow perspective. So there's data capture, there's processing that happens, there's management of that data, and most importantly, making it applicable to the end users that are leveraging our technology. And that's really what we're going to talk about today is some of the enhancements, some of the things that are happening, the path that we're on, so that you have a better understanding of that. And it's really about leveraging ArcGIS to get the full value of your imagery and point cloud data. And one other point, it is incredibly important for us that we have a very strong business partner network. They are a big part of your trusted advisors to get this work done the right way. So I want to make sure people know about our business partner networks too. We break the data categories down into kind of two primary models. One is images that are used for inspections and audits and those types of things. We consider oriented images, and we've been supporting that kind of work for our GIS customers for many, many years. I remember 22 years ago working with a transmission organization. They were already using a Ryko camera and a GPS receiver attached to it to collect images of their transmission assets, and it went in as an asset in GIS. So we've been doing that for many years. I just came from a conference where most of the room was leveraging Esri to document and capture information about their assets as they did work in the field. The other category is our mapping products. That includes point clouds for surface models. It includes digital orthos. It includes things like 3D mesh Folks may not know about our new Gaussian splat capabilities. Cody's going to go through a number of these things today, but it's really applying a block of images or a collection methodology to build a very accurate, map accurate representation of that data so you can leverage it more effectively across multiple departments. So a couple of examples of that include recently posted user stories that we have. One is Sulphur Springs Valley working with Aerial Sphere, one of our trusted business partners, who has helped them in their data collection. They are collecting images of their distribution assets and poles, and in that process are leveraging the Aerial Sphere tools to quickly, with our APIs and capabilities, to quickly load that data so that it can effectively be used in our oriented image catalog to address the business requirements that they have across the organization, with the benefit of being able to share and collaborate across all of the users within the organization through our server technology or our mobile technology, those kinds of things. The other example is just posted and will actually be in Arc News, is the city of Stark, Florida. So our two of our business partners, 1898 and Co. and Noteworthy, work together to really effectively start from scratch. In this case, the customer's data, the small municipal, but they looked at it and said, you know, our old paper maps and some of the things that we have aren't really up to date. So they took the approach of, let's go out and collect new data, leveraging Noteworthy's vehicle mobile data collection capabilities, and collected all the data within a couple of days, 7 hours of drive time, which now effectively helped them immediately build a new representation of all their GIS infrastructure assets, and leverage our ArcGIS Online tools to effectively support grid planning and maintenance and storm response, and even started generating more revenue from the joint use and foreign attachments that they realized that they had that were not up to date in their old methodologies. So this is just a couple of examples where they improved the accuracy of their data significantly and immediately built a new set of data for GIS that is now much more effective for the use that they have. With that, I'm going to pass it over to Cody, and he's going to do a little deeper dive into our technology.
Great. And thank you, Todd and Ken, for having us here today. And thank you, Tom, for that introduction. My name's Cody Welch, and I'm a solution engineer here at Esri. And today we're going to talk about what's new and our roadmap for imagery and 3D data within ArcGIS. I'm really excited about this. So thank you guys for your time, and I'm excited to have you all here with us. So like Tom mentioned, ArcGIS is a comprehensive imagery and remote sensing platform. And we really break that into 4 pillars when we think about imagery and remotely sensed content. That can be the management side of data, which is really that foundational piece, right? That's how we start to exploit the content that we already have or that we leverage from our business partners or our providers and make actionable insights from that. And that would be in our next pillar of analysis, where we're starting to take those pixels and exploit information from them. And ultimately, ArcGIS allows us to visualize that data, whether that be in a 2D or a 3D context. And then this 4th pillar here is called reality mapping, which we'll talk about as well. But that's where we can go and curate and capture our own content that we supplement with the data that we already have. And this can be from drones, aerial cameras, and satellites to build foundational 2D and 3D content that feeds into those downstream pillars that we just discussed. So let's see what that looks like. Here's an example of a 3D scene in the web of all different types of content together that allows us to get a real representation of our assets in a view that allows us to give us that 3D perspective of what we're used to seeing in the real world. Here we can see that we have our right-of-way alongside all the 3D base map behind us. And we can pair that with point cloud data that's been analyzed. So using our analysis tools to classify that data, right? So we can see the towers have been extracted, our lines, vegetation, and buildings, and even the ground all classified into their different returns. With that, we can start to unlock information from these data sets. So we can see vegetation encroaching on our lines. And to provide additional context, we can add in some of those new data types like the Gaussian splat, which is a super high fidelity visualization of the same area of interest to see how things align. Because ultimately, accuracy is very important when it comes to our everyday workflows. And we'll talk more about that as we dive into each of the capabilities and why that accuracy matters. As we continue to look through our scene, we can provide that additional context that we want to view. So if we want to see another shot of our lines, view that with our point cloud or back to just our splat representation, we have that here to view. And then we can even pair that with some deeper analysis such as buffering to see where we might have possible intersects to actually highlight trees that are growing within our distribution right away. We can flag those and then ultimately validate against the same images that were captured. So in this example, we've captured once and used many different ways. So as I select one of these points that are above us here, we see that individual image and we can actually open that up and start to zoom in and validate what we're seeing in our imagery. This is just a quick example of what I mean by a comprehensive imagery platform. So to review what we just saw and break back down those 4 pillars, this is what ArcGIS as a imagery platform can provide to us. All those different modalities that we just saw, such as the 3D Gaussian splats, point clouds, aerial imagery, and others, together in one scene that have allowed us to perform analysis and then share an experience for our users downstream or throughout our organization. So let's start with one of these pillars and what's new in data management. To me, this is that foundational piece that allows all of that downstream things that we just saw to really shine and manage all of this unstructured data for us. And what I want to highlight on this slide here is that when we talk about remotely sensed content, we're talking about vast forms of modalities and different types of imagery, such as elevation, scanned or historical photos, video, 3D mesh, oriented imagery like we saw earlier, and we'll dive into a little bit deeper, and even point cloud data. I know it's always, point clouds can seem extremely scary, but they're large, they're a lot of points, a lot hard to visualize. We try to make that easy for you alongside all this additional content. And what we like to do in this management format is take all of that and consolidate that into foundational data models that allow us to take what used to be multiple individual files and put it in a unified footprint, such as a mosaic data set or a LAS data set, to be able to look at all of that area together in one unified footprint so that we can perform our analysis across all of that data. So like I just mentioned, all of those formats and modalities can be used into those different data models, like we talked about, such as the mosaic, the LAS data set, oriented image data sets, and more, to essentially effectively share and stream this content, whether that be through image services and the enterprise architecture or hosted imagery through online and SaaS offerings. All of these data models play within each side of the organization so that you can do the work that truly matters, such as performing analysis, doing feature extraction, or doing extensive visualization that come together in that unified view that can be shared to everyone and all of your stakeholders at the same time. So you've heard us mention it a few times. We probably are, I guess we're pretty excited about oriented imagery. What this is the ability to take all this unstructured data, such as street level photos, 360 panoramas, videos or images from drones, video files, aerial captures, that aren't traditionally captured from the native view. These are going to be your oblique captures, or like I said, street level. So you're just grabbing a phone and taking shots, or your tablets, whatever that may be. This oriented image data model allows you to turn that into a geospatial asset and allows you to view that imagery from any angle and simplify search and discovery. Again, accuracy matters with this because we know that inherently imagery can have a shift depending on what device it was captured with. So the more refined the data is when it goes in, the better the outputs are. So what do I mean by that? So like in this example, we can see all the images were actually captured, but that accuracy helps us actually refine that field of view alongside it. So as you see how the image zooms in, that field of view refines with it. And because of that, that means that our accuracy is in a good place. And the more we add, the more we can do, such as navigate through all of these images, perform measurements, do feature overlay, etc. This data model empowers you to make the most of all that unstructured data in a simple and easy way to manage, visualize, and share. Just like I mentioned with the oriented image data sets, we can do the same thing with Lidar and point clouds. And I distinguish the two because technically you could say, well, Lidar is a point cloud. Yes, you're right. Well, there's also the photogrammetric derived point clouds like we saw from drone capture. So different collection methods can result in different accuracies. So again, it comes down to accuracy being very important because the more accurate your data is, the more valuable it becomes downstream. And these data models allow us to store and manage those massive volumes of point clouds, and they are easily accessible and ready for analysis. And that means that we can extract height measurements from this, perform surface analysis, and even leverage AI for pre-trained and customized classification models. So like we saw in the first example where we had the point cloud broken into different features, that leveraged AI to do that classification for us and automated our process. And ultimately, this allows us to create those detailed 3D models for realistic visualization and asset management.
Hey, Cody, we do have a question from the
Sure.
audience. Here at PG&E, our engineers primarily use classified LiDAR data processed in PLS CAD. Is there
Okay.
an existing process or a future roadmap item for ingesting PLS CAD data into ArcGIS?
That's a great question. So as of right now, there hasn't been anything on the roadmap. However, we are expanding the data types. So we recently moved from just supporting LAS only files into supporting LAS and LAZ. And so if these are continued requirements from that process data standpoint that you're looking for, please let us know and we're happy to work with you on those.
I will also add to that, Todd, that we do have business partners that have services that do that. There's a handful of them, so we can help get some of that information to the customer in this case.
Great. So another data management tool that I'd like to highlight is our ability to work with the spatiotemporal asset catalogs. And I know that's a mouthful. So you'll commonly hear this referred to as STAC, which is more of a data specification that relies on metadata. And what it allows us to do is store and manage massive volumes of data. And we can see this used through examples like the Microsoft Planetary Computer or others, where essentially what this allows us to do is query against volumes of open data that allow us to bring this in. And these can be stack catalogs that you've created yourself or others have provided them to you, but essentially it allows you to hit all that open data without you having to go find it, download it, bring it in, so on and so forth. It integrates that directly into the desktop experience to where you can search and discover and then perform analysis on those data sets. This is extremely valuable because it makes it easy to find what you need when you need it and bring it right into your workflows. So now that we've hit some of the what's new with the data management pieces, let's expand into reality mapping. What is reality mapping at Esri? Reality mapping allows us to create accurate digital representations of the world around us. And that's generating that foundational content. So where we just talked about managing all the content we may have, what if we have gaps? So when we do something called reality mapping, that allows us to fill those gaps and create that foundational content along the way. So that can go back and be that oriented imagery data set. It can be data that you've collected to create 3D mesh or Gaussian splats, those photogrammetric point clouds and true orthomosaics. All of that counts as that foundational content. And again, with accuracy in mind, all of this data is up to date, accurate, and analysis ready when you produce it. And so using the photogrammetric process, we can take those raw frames that you're collecting and generate that foundational content. And ultimately, it allows us to build that intuitive GIS. As we continue to grow in our organizations, we see things moving from 2D to 3D. I know digital twin is a big word nowadays that we hear all the time, and this helps set us up that baseline foundation to get us to that point. So when we talk about ArcGIS reality at Esri, we're really talking about that digital photogrammetry experience catered for a different user type or user group, depending on what your job requires. So it's all powered by the Reality engine, hence the name ArcGIS Reality. But that comes with 4 distinct products. Included in that is the drone offerings for ArcGIS Drone to Map and ArcGIS Site Scan, or Site Scan for ArcGIS. And the one thing about Site Scan is that it's our SaaS offering. So everything's done in the cloud, and you can store massive volumes of data there, produce your results, and share those seamlessly into your downstream organizations, whether online or enterprise. Drone to Map will allow us to do the same things, except we do that localized on our desktops. Now, if we wanted to expand outside of the general site-wide collections and look at large-scale collections, that's where we see tools such as Reality Studio or Reality for Pro come into play. Reality Studio is built more so for the large aerial cameras, the big 5-headed, finely tuned cameras that are typically used for like city, county, and countrywide mapping. And then ArcGIS Reality for ArcGIS Pro is integrated into that desktop experience, and it takes all 3 modalities. So that means you can work with drone data, aerial cameras, and satellite to generate that foundational content. And if you're typically working with drones, we also offer the ability to flight plan using ArcGIS Flight, and it seamlessly integrates into our Reality products. So what's new within this set of tooling? So from a flight planning standpoint, we've expanded support for drones to include the DJI M3E and the M4E. Look to expand into a government edition of the flight app, and also expanded support for Blue UAS certified drones such as the FreeFly Astro Max. Our flight planning app allows you to integrate with all the content that exists within your organization, whether that be online or enterprise, to help you better plan missions and autonomously fly your drones while keeping track of all the required information such as FAA authorizations, pre-flight checklist, pilot information, and all the drone related information you may need.
Cody, we've got a couple other questions if
sure.
that just popped up.
Sure.
How do we keep high performance when there's so much near real-time imagery available? I would like to combine this with utility network data.
Excellent. So that's a great question and things that we're working on. And then again, it comes down to that management piece. And we're happy to talk more about this because there's a lot of nuances to consider. However, this is where we see a lot of things like our server technology come into play to help streamline the process and not only manage the data, but interface in with the repositories that you already have. So if you're storing data locally in file shares or in cloud storage or wherever that may be, you can set up that technology to integrate directly with that so you don't duplicate and you reference, which is extremely important because, you know, me working with imagery data and doing downstream analysis, I don't want 1,000 copies of something just to get to an endpoint. This allows us to reference that original data set and do our downstream work without ever duplicating it along the way. So there's definitely worth a deeper conversation there, but there are ways we can help expedite and streamline those processes. Hopefully that helps answer your question.
Awesome. Thanks, Cody. One other question. How has the feedback from subject matter experts been with the deployment of this technology for encroaching vegetation? Do they find it accurate? Do they find it over-identifying work, etc.?
That's a great question. In some of the examples that we've seen, it has been very well received. But again, it comes down to the accuracy in which the data is collected. Where we see some not so great results is if, say, especially if we're curating our own content, is if ground control is not in part of the process, right? So drones especially, or any device, they're not spending money on the GPS usually. They're spending money on the technology around it. So in those cases, you have anywhere from a 2 to 6 foot shift. If we don't account for that, then our data doesn't really mean much at the end because we're not looking at where it exists actually on the planet, right? So it's really important to have that side of it. But when those things are accounted for, and you start to pair that with a downstream analysis like GeoAI, if you go through the process and get your models to where you want them to be from an accuracy standpoint, you can greatly expedite your workflows and know that it's accurate in the downstream outputs with minor tuning on the end. So again, it's a little bit deeper and worth a discussion if it's something you're interested in, but hopefully that helps set the stage for the things that are possible within the technology. You just kind of have to put the front end piece in it as well to ensure that you're getting the best results downstream.
Awesome. Thanks, Cody.
You're welcome. So when we look at drone to map, again, this is our desktop-based drone solution. Some of those new enhancements are the Gaussian splat generation. So again, these are the new 3D models that are created as 3D tiles that are super high fidelity representations of your captures. There are some additional considerations when going to fly to capture for these that are worth acknowledging, such as higher overlap, to ensure that you're getting all sides of your assets captured properly. However, this does great for wireframe structures, so in thin structures. So these Gaussian splats are using, it's still a photogrammetric process. However, it's leveraging neural networks on the back end to help generate this output. And so it's a really nice visualization that you can get around your assets. And then you pair it with that additional content, such as Lidar and other things, to really expand your capabilities for measuring, to extract, so on and so forth. And we're continuing to expand upon what the splat can offer, to lean into being able to extract from the splat itself, and so on and so forth. But the fact that we're able to generate these is really exciting to me, especially for utilities and your workflows, because the fidelity of the output is extraordinary.
Cody, we had a few more questions just
Sure.
pop up. The first one is, can you define a set of points where you want a drone to fly to, stop, and take a picture, then move to the next point?
Yeah, so we've been working on waypoint missions to do that. That would definitely be worth kind of an offline conversation with our drone teams. That business case we've looked at, I'm not sure if we've implemented it yet. We do allow for inspections where you can manually control and not do automated. But the waypoint mission has been a request that I would definitely like to dive in further.
Awesome. All right, next one. Does Drone to Map currently support Gaussian splats, or is that only available with ArcGIS Reality for ArcGIS Pro?
So yes, the new version of Drone to Map does support Gaussian splat generation. You just have to ensure that you install that deep learning installer so that the proper neural networks are embedded inside Drone to Map.
Okay, awesome. And last one, I think for now, does ArcGIS flight work with NDAA compliant drones? For example, Skydio, Census Tech, etc.
Great question. So when the R-Flight app was developed, it was developed when DJI predominantly had the market share. So most of our supported drones still are around DJI outside of the free fly drones that we talked about earlier. With that shift, though, however, I know a lot of the market has moved away, given certain bans, things like that around DJI. We've started to expand our partnerships with companies such as Skydio and things like that. So, for example, in the Skydio integration, we don't control the flight planning. You still do that within Skydio's controller. However, there is an integration directly from Skydio to SiteScan. So what that allows you to do is plan your missions, go collect with the Skydio controller, and then it feeds the data right into our SiteScan cloud processing, and it'll generate the products, and you have all of that available to you. Those downstream workflows right there from SiteScan. So it's kind of a bridge, but it allows you to do that with Skydio, for example. But I will caveat that if flight planning, one thing about that is feel free to use any flight planning that makes sense to you. All we really care about from a processing standpoint is that the images that you collect have the appropriate geolocation information in them. And most modern sensors do this. So, you know, when you upload your imagery to it, it'll tell you, hey, it's missing the location information. And so if it has something that your images are captured and you have an associated CSV, you would bring those together and then upload it. However, we are sensor agnostic from that standpoint. What we talk about the limitations is only in the flight planning piece.
Awesome. We had I think a couple more come in. What are the benefits of Gaussian splats? Are they smaller? Are they faster? Or are they just higher quality?
All of the above. I hope that helps. But with the 3D tile output, it definitely streamlines visualization, rendering, smaller footprints, and then the output fidelity is fantastic.
Okay, and I think this may have been answered, but let me go ahead and ask this one. In the past, photogrammetric methods struggled to capture thin objects in 3D, like distribution, conductor, and telecom cables. Do you know if Gaussian splats does any better with these types of objects?
Absolutely. And that's kind of what there's, you know, from my perspective, that's where they really shine. There's some examples that we're happy to share from where we demonstrated some of this around a substation at IMGIS last year that used the Gaussian splat. Again, the biggest consideration is around your capture, where you want to increase your overlaps for these. And the better the sensor, the better the output. But absolutely, you do not see some of those, what I like to call wrapping, like especially around thin frames, you know, where you're getting the background folded around the tower or things like that. It doesn't do that. The refinement process itself really shines around those thin structures. So you can see wires, you can see conductors, you can see bundles of wire, so on and so forth.
Awesome, Cody. Okay, I think we're caught up. Keep the questions coming, but go ahead and keep going, Cody.
Sure. All right. So let's keep rolling here just to ensure that we get through everything. So site scan for ArcGIS, again, this is our cloud offering. Like we just mentioned, we have the Skydio cloud integration now. There's expanded publishing tool sets and features available in our web manager, so you can do enhanced measurements, support for all coordinate systems from a vertical standpoint. And then the Gaussian splats will be coming soon to this tool set as well. So again, we're really trying to keep all of these offerings from the Reality Suite standpoint equivalent in what they're able to do. And it's just really designed for what you want to do as the user. And all of these support GCP workflows. So you can bring in your ground control, RTK and PPK corrected photos are supported. And then when we think about Pro, because you're already in the desktop, you have that expanded set of tools around you already available to you. So if you want to do mesh editing or you know, do analysis right there in the desktop, you have those tools beside you. I just saw the question come in about a fully automated reality mapping workflow. If using Reality for Pro, yes, and we've already documented that. The one piece that's still a manual process is the ground control process, just because you need to have eyes on to ensure that you're locking your targets in. But outside of that, you can fully automate the process of creating the workspace and then set it through downstream to do your processing from there. All right. So in our last part, we've talked a lot about the new, what's coming from the reality side, the management, and lastly, I'd like to talk about visualizations. So this is the most important part and what's fun about this, right? We've got all this content, we've curated it, we've collected it. Now, how do I share it and how do I use it? So one thing I like to highlight, especially from the Esri standpoint, is the Living Atlas. And this is a ton of curated content that is available to you as an Esri user. And it doesn't just need to be imagery here. This is all tons of data. So that includes weather and climate information, so wildfire events, weather warnings, drought conditions, all of that's available to you. And we have an expanded partner network that continues to feed this. So Barren Weather is one that I like to call out for the weather side. They continually expand their warnings and their data products from the weather side that's continually fed into the Living Atlas and is updated. So that's available to you. You have tons of imagery and vector data sets. So if you want to look at a unified image service of NAPE, instead of having to go cut out individual tiles of a NAPE image collection, that whole image service is available to you right now. You could look at historical imagery, that's there too, and satellite photos, everything, all within the Living Atlas. Outside of the content, there's also tool sets that you can work with. And I really like to highlight the GeoAI models. So at Esri, we offer pre-trained GeoAI models that can be leveraged on imagery right now through the Living Atlas. And I think I checked yesterday and there's 104. And these are continually updated with new models. And I was pretty excited to see that we just updated and released this Segment Anything 3 model from Meta. So it's been a super refined version of the Segment Anything model that released a couple years ago. And I find that I use that quite a bit to do GeoAI workflows, whether that be, extracting features, looking for individual objects, so on and so forth. That model really expedites the process and allows you to do kind of a hybrid approach of taking a pre-trained model and then refining it to meet your needs, or just running it on your imagery. But as a whole, outside of that, all these models that are available can get you to a baseline. Will I say they're going to be 100% accurate? No. However, they're all available around different percentages of accuracy that you can refine and work through to improve should you need to. And each model comes with a guide that tells you how to use it, what type of imagery it's been trained on, the resolution, and how you could refine that model should you need to do so.
Hey, Cody, we got a few more questions that just came in, if that's okay.
Yep.
Is it possible to have a fully automated, I think, reality mapping workflow?
Yeah, so I hit on that. I saw that one come in. That one has already been documented and it's available, and we can share that.
Okay, can Gaussian Splat identify the electric lines, equipment, and all attachments that are on a pole, such as telecom and fiber? Can it let us measure from the ground to the lowest hanging attachment for clearance issues?
So you can absolutely do measuring against these, yes. And again, it goes down to the accuracy of your collection, the accuracy of your collection method and your overlaps to ensure you're getting the best product. But if you ensure that you're hitting all of that in the process, you can absolutely have a product that allows you to do exactly that. I've seen some older data sets that have been around that were not flown with the best overlap and so on and so forth, of like telco towers and so on and so forth, that you can actually see the wires inside the tower and then the bundles and slack at the bottom. I mean, so you're getting that level of detail within those structures. Again, it just comes down to ensuring that when you go to collect, that you're doing it the right way to make sure that that level of fidelity is brought out in those output products.
Awesome. Okay, a few more. Does Esri support imagery stored in secured cloud buckets, cloud storage buckets, for example, Azure blobs yet, or does the imagery still need to be publicly available?
This is a fantastic question, and I'm assuming that we're referring to oriented imagery. So with oriented imagery, we currently at 11.5 have a method to work with data that's in a secure blob or S3 that is called custom data feeds with Enterprise 11.5. And this allows you to set up a kind of a pipeline to allow you to pass those back and forth. However, moving into hopefully 12.2 or 12.3, secure buckets will be fully supported within oriented imagery without having to set up that data pipeline. So we're not there yet, but this has been a highly requested feature and something that I've worked closely with Tom and others on our team to get to our dev teams to ensure that this is something that is addressed, because we know that in our space particularly, that this data can't be floating around in those publicly available storage containers.
Awesome. Thanks, Cody. A couple more.
You're welcome.
Interested in learning more. Does this imagery cover Southern Africa and Swaziland?
I'll be honest, I don't know offhand, but I do know a lot of our imagery data sets are worldwide coverage. So we'd want to make sure together that we have what you're looking for, but I would not be surprised if there is something, especially within the Living Atlas, that can provide that to you.
Okay, and I think the last one for now, would you be able to share the documentation at the end of the session on how to automate the creation of reality mapping workspace? So far, we've only been able to automate the process after the project creation.
Yes, absolutely. I can share that with you. It starts in Model Builder and you piece it together, but once it's there, you can export that as a Python script that can be run on task or at however you need to. So I'll be happy to share that.
Hey,
We
Cody,
have a couple
Cody,
more
I'm
too.
gonna add to that, Cody. You're putting together a kind of a new video here in the near future that's kind of start to finish workflows also, right? That'll
Yes,
help people
absolutely.
understand how to use our tools. Yep.
Absolutely.
Cool. And for audience, thank you so much for the interaction on this. This is great. A few more questions came in, Cody. How does the Skydio image data capture integrate with in-field Esri apps, site scan, and then how does the upload process work? Oriented images in cloud question mark.
Great question. So from the Skydio perspective, like I said, it would be like there's a connector that Skydio offers, and if you have, say, the site scan license, you'd be able to set that up through the Skydio end, and it allows you to basically integrate and work from there. So if you're out flying your Skydio drones, you can have that. You would have a connector set up basically to do so, and it would push the imagery directly to site scan. And that's kind of where it tapers off from the Skydio perspective. You're just using them for flight controlling. But what's really great is because, like you asked about OI and some of the features for are using that data down in downstream mobile apps, things like that. Once you have it in SiteScan and you generate your outputs, that's available to anywhere in your organization, whether it be online or enterprise. You can download it locally. You can share web services if you don't want to do any sharing into your orgs. Those tools are all available through SiteScan that can get it to those downstream endpoints. And once it's in the system, it's accessible to anyone in the organization from any part of the platform, whether that be field, mobile, web, or desktop.
Awesome. Okay, the next one is how are the pre-trained models accuracy validated? How are the pre-trained models accuracy validated?
Great question. So a lot of our models they're trained using our Python APIs, and they actually kick out metrics. So our dev team spend a lot of time working with these tools as they come out, and then they validate their accuracies if they need to be refined, so on and so forth. And each one varies, right? Each one will have a different level of accuracy that we offer from them. So, I mean, some of them can be 70%, some of them will be up to 80. We try to keep it generic because, again, these things aren't going to be perfect, but if they're designed in that kind of range, is getting you 70, 80% of the work done, right? And I will always recommend, as with AI in general, is you've got to validate the output, right? There's always going to be that QA QC piece. But if if I can run these and get 90, 80% of the way there, then that helps me in that process. So when we validate these, our dev teams are doing that training, they're getting those metrics, and when they get it into that spot, they roll them out. And those training data sets are all listed in the documentation. So depending on which one you pick, you'll see the metrics, how it was derived, what backbones that were used to get you there, and then how you could implement that within your organization as well.
Awesome. Several more questions have come through, Cody.
Sure.
We will absolutely get to all these regardless. Cody, do you want to keep going through the presentation or you want me to keep giving you questions?
I have a few more things if we can run through that really quick, and then I'll try to leave some time.
And everyone that's asked questions, we have captured these and we will make sure that we get answers back to you if we do run out of time, but we'll let Cody keep going.
Cool. So the last couple of things I want to hit here from a visualization standpoint, especially in the web, because this has been exciting. Traditionally our imagery workflows have been within the desktop. And that's all fun and well and good to do things in the desktop, but I don't know about you guys. I don't always want somebody to be like, hey, come check out my office, come do this. I just want to share it with them, right? And I don't want to have to pass them a hard drive or a file on a folder or something like that. So we've really spent a lot of time expanding the tool sets within the web environments to really deliver a true imagery workflow and analysis capability set right there in the web using image services. So some of those enhancements have been around hyperspectral support, which is a big deal if you're using those types of sensors. Expanded raster functions, which really quick, a raster function means that I don't have to go and run a process, wait for it to finish, get that output, and then feed it into the next part of the process that I'm doing from an analysis standpoint. A raster function allows me to do a quick analysis, such as slope assessments or things like that on the fly. So when I apply a raster function, I just hit that function and then I get a visualization, and it doesn't write it out. It's all in memory. So it gives you that visualization that can be used for downstream without writing out new data. And those are extremely powerful for complex analysis workflows. We've also expanded our oriented imagery viewer. So as you see in this little video here, we've kind of moved where that viewer is, how you can interact with it, enabled time within that viewer so you can see the catalog changing over time, and multi-catalog support is within this as well. Or data set, sorry, not a catalog, it's an oriented image data set. But you can work with these within that tool set. And then overall, we've expanded the tool sets in Experience Builder as well to try to unify this. Like I said at the beginning, we're a remote sensing, imagery and remote sensing platform. So things that you can do on the desktop, we're making those available to you across the entire system. And one that I'm really excited about is the Google 3D base map. So in that example we showed at the beginning, we had our Gaussian splat laid through of our right-of-way, and then we had the 3D map behind us. Well, that's actually the Google 3D photorealistic base map, and it allows us to cut out areas around our content and supplement within it. So what you saw in that beginning example was my data that I've curated, laid in, and then that additional 3D base map was provided for context. So as we zoom around, we have that data set available to us with our data on top, and it really streamlines that view. So I was excited about that one. And then we've got video capabilities in ArcGIS, right? So we talked about flight planning. Our flight planning app collects in what is called MISB compliant, MISB compliance, which is the Motion Industry Standard Board. And it's the metadata specification that allows you to create what we call geospatial video. That's where when you are not just looking at the feed, you're also seeing the feed alongside what the sensor was looking at, the trail around it, and being able to have that additional context. So like we see with oriented imagery, where you have the frustum and what the sensor saw, you're getting that same type of experience, but you're doing that from a video feed. And so video in ArcGIS has been expanded to allow us to work with this content, and we can do that locally within the desktop environment or throughout the web, leveraging Video Server and ArcGIS Excalibur. Geospatial video format was MISB compliant, so MISB. And for our tool sets, it would just be full motion video. So again, when you work with the video, it basically allows you to hit those same pillars that we saw earlier, from managing it to search and discover, to do visualization and exploitation and analysis, all within the same ArcGIS system that we've been discussing today. And ultimately, this leads us from imagery to the digital twin. I know that's where we want to go. We want to move out of this 2D world into those 3D representations. And so those types of digital twins that we're talking about can be environmental monitoring, spatial planning twins, digital or design and construction. In our case, we're really interested in network management and operations and maintenance. And so when we think about digital twins as a whole, it's really like a process, right? They're not just one thing that just happens. It's a move to a new way of thinking, and kind of in phases. So as you see here, we see it kind of moving up this trend, right? So everything we've talked about today, especially from the reality mapping and so on and so forth, that's really this bottom tier, which is that foundational piece, that descriptive digital twin, right? That gives us the foundational view that we can do analysis on, and have that 2D, 3D visualization that we've seen. But then we can start, once we have that foundation in place, we can start moving up the curve, right? We can start moving into that informative, where we're pairing that with IoT sensors and GeoAI. And then you move into that predictive, when, okay, now I want to use Gen AI and machine learning to forecast, see events before they happen. And then you get into comprehensive and autonomous. So again, it's not this thing that just will happen. Again, it's one of those things we really want to say that everything we've talked about today really helps us set that foundation for where we can go with the digital twin. And what we've seen today is really that endpoint there. So I'll end out here again and just kind of take us back to what we saw at the very beginning. So now that we have all that context, remember, this is putting it all together. So we have the Gaussian splat laid here. And again, this one may not have been flown the best to get the super high resolution that we were looking for around lines and towers, but it gives us a much better representation than what we had. And then that's paired with the Lidar that's been classified. And then you can do those downstream workflows like we saw with the encroachment, and even pair that with the source imagery. So we're using once and collecting many, or using once in many different ways. I'm sorry, let me try that one more time. We're collecting once and using it in many different ways. And that's an extremely valuable proposition. We're not duplicating data. We're not going to collect the same area over and over. We're not requesting that we go buy the same area over and over. We're able to take that one set of data, manage it, create foundational content, perform analysis, and ultimately end up in a visualization like we see here. So I really want to thank you all for your time. We have about 5 minutes left, and if I can answer any more questions within that time frame, I'm happy to do so. But thank you again,
All right.
guys.
All right, Cody, I'll start getting to the ones that I think we left off at. Is there or will there be a Geo AI feature extraction model for Gaussian splats?
I am unsure of that at this time. Again, we are continuing to expand what the Splat can offer. And I know feature extraction is in the roadmap. I just don't have a timeline if we would move into like a Geo AI model that we curate to do that. But definitely something that we're interested in doing.
Awesome. Okay, the next one, does ArcGIS Pro stack integration support visualization of oblique imagery stored in S3 and served via Stack API?
Yeah, so you can exploit that. We've seen this done. And again, we've definitely leveraged our partners. And Tom, if you want to help me with this one too, but we've leveraged our partners to really help exploit that and work with large scale collections of oblique imagery, especially around substations and so on and so forth. But that specification, you can absolutely use it within Pro to view them, and then bring them into your data sets to perform tool sets on.
Great. Okay, the next one, is there feature parity between ArcGIS Online and ArcGIS Enterprise for supporting imagery in web?
Great question. So with ArcGIS Online, it's SaaS. So when those updates roll out, like we talked about with the like some of the enhanced support with like OI, the new viewers, things like that, that's at the current version of AGOL. Traditionally, these are behind, our enterprise is going to be behind that because you're looking at, on-site implementations of it. So some of these tools that you're seeing wouldn't be current until maybe 12.0 or 12.2 in enterprise, especially around some of the oriented imagery tool sets and things like that. So I always try to say it's going to be, online is going to be the most current, and then enterprise will be a version or two behind that.
Okay, great. If we start collecting oriented imagery and start providing it through our web apps, where would we store the data and in what format?
Great question. So you have some options with oriented imagery, depending on the scale. Some of the supported formats right now are hosting abilities, I should say, are being able to add those as feature attachments, which again, that's kind of hit or miss depending on the amount. If it's a small scale flight or, not a ton of imagery, you can get away with that. Now, when you move into maybe, 30,000 images per asset, that's not going to cut it, right, as a attachment. So some of the other offerings are, again, right now you could store it in the cloud. Public access is one of those things you have to watch for. But there's also a workflow that I've gone through that I'm happy to help with, is configuring like a web server within your organization to allow your data to remain behind your firewalls, but then communicate through your web server to access through the experiences and so on and so forth. And you're keeping your data in-house. But that's more of a internal outside of Esri workflow. But again, it's been done and I'm happy to help with that.
Awesome. Okay. Is either Skydio X10 or DJI M350 400 recording MISB compatible video yet?
Ooh, I am not sure if their sensors do that or not. That would be something I have to check on. I don't know if they do that by default. Our flight app does it. So, that's one of the things. If you used a compatible drone within our flight software, we do that for you. So it doesn't so much matter about the sensor itself. We're handling that. I'm not sure if DJI or Skydio has embedded that into their controls or not.
Okay. A couple more. Can you confirm that ArcGIS Reality for ArcGIS Pro is required if you want to build an automated workflow ArcGIS Enterprise? And then will automated Python workflows ever be supported in drone to map?
Great question. So I'll hit the second one first. I don't see drone to map going that route, especially with the enhancements around site scan and things. I would actually could see those becoming kind of like a unified approach, but I'm not sure about the Python side. Now to the automation or around the question around Reality for Pro. Yes, if you want to do those automated workflows where you're building the script around Reality workspaces, yes, you would need to have Reality for Pro, and then you build the model builder because essentially it's all geoprocessing tools that are handling it, so you can script it and build models from that.
Great. Okay. Looks like we have one more question and then one hand up. So we'll end with that. Will the Google 3D base maps be available in Enterprise?
It should be in the later versions. Yes, you could access it through like online now if you enable it. It's in beta. So in your organization, like again, it's not going to be an enterprise yet, but if you wanted to use it through desktop and you had access to online, you can enable it through your organization settings. It's a beta period right now, so you have some credits available to your org to access it. And when you do enable it, it's available in your desktop environment as well.
I think that's it for now, but great job, Cody. And again, audience, thanks so much for asking all the questions and keeping this interactive. That was a lot of great information.
Yes, thank you all, and I really appreciate it. Thanks for having us.
Absolutely.
Yeah, thanks for
Well,
having us. Hey, Ken, I'm going to make one more point. So
okay.
from the questions that came in today, it helped us on some other topics that we'll try to cover in the succeeding sessions that we do, because we're going to be doing things around inspections, and then we're going to be doing stuff around risk management and then event management. So there's a couple of these topics we can probably cover in a little deeper dive on those sessions. So this was really good feedback today. Really appreciate everybody participating.
Absolutely. Thanks to you, Tom, and you, Cody, for doing this. Thanks for everyone who's attended this. We'll make sure to follow up and again be on the lookout for that next in the series of these webinars with Esri. That's going to be coming down the pike in the June timeframe. So we'll be getting you information well ahead of time on that. But again, we really appreciate everyone on the call, and we will talk to you soon.